Imagine being able to generate realistic lip movements from just a line of text. So, no microphone, no audio, just pure visual speech. This has powerful application in virtual assistants, silent speech interfaces, for the speech impaired, AI dubbing, and even animation pipelines. With that vision in mind, I started this project by empathizing with both the creative and the accessibility needs of users. I defined the problem as how can we convert plain text into visually accurate lip movements without relying on audio at all. Now, this then came the ideation. So, I mapped the phonemes from the text to a set of 12 Visme classes. These represent distinct mouth shapes like open, closed, round, uh, like these. Instead of training one large model, we trained separate GANs for each Visme class using the TCG timid dataset. Now, each GAN specializes in generating a short lip motion clip for its own Visme. So, I have a GAN for closed lips, I have a GAN for teeth touching, for open mouth, etc. Now, we prototyped a dynamic pipeline that takes text as input, converts it into phonemes, and then maps those phonemes to the Vismes. Vismes are the lip shapes, these. And then passes them through the corresponding GANs to generate video frames. We will also be including like frame blending to make the transitions between these Vismes smooth and realistic. Now, we tested this app. So, this is my final prototype display. So if I just want to run it on code, what I will do is I will just run this once. I will enter a word, so like goat, and then it will get distributed or split into its subsequent phonemes like G, O, W, T. All these phonemes together make the word goat. Now each phenome has a GAN in the backend which is running to generate the lip shape of this particular phenome, and these are the prediction durations. So we also have a model for predicting the duration for which a particular phenome should be generated. Since we are not using audio, we don't know the timestamp of every word, of every letter in the word. So this is what we are doing. We are just predicting the duration, and depending on the duration, we are calculating the number of frames. Our frame rate is 100 frames like per second. Okay, and then we have all these generated like images. I will show it to you, and the PNG, GIF, and MP4 videos are stored here. Now let's see where it is stored. So in merge GANs, I have all these words which I've created, which are stored here. Right now we did goat. Let's find goat. This one. So if I see, it's not very clear, but it's trying to say goat. Now it's not very clear because I have not even used 25% of the data set to train, because it took me 3 months to train 12 Visme classes, and I reduced the data set so that I could train a bit faster. But if I like have more GPU, I think I can do training a bit faster, and I can train it on the entire data set. That will improve the image quality, and I think that will improve the generalize the lips also a little bit. This is the GitHub file where I have uploaded in my entire project. This is where I have made the project locally. Here also I have tried to make it. There was some error, so I ran it in Colab. But I have fixed it now. It should work. I've created cat. So like each frame is generated like this, and then there's a GIF, and then there's an MP4. Now MP4, the video is too short, which is why it is not working. But if we reduce the speed by which the frames are moving, I think the video should work too. This is still an ongoing project. I have also made this so that you guys can try it out yourself. So if I'm writing, let's type a simple word, hello. It should generate how the hello word would be spoken. Now these images are not very clear because the part of the data set for these was a little less. I will show you the data set also. Now these are the cropped images. Now these are the number of classes that I trained my data set on. This is how I pre-processed it. After pre-processing, I was left with 12 classes. Each classes has like about 1000 clips, and each clip is then divided into number of like each frame. So like this is closed lip. So person saying something with a closed lip, this is how it would be said. So what I did is my dataset, TC-rate image dataset has like one person saying about 100 sentences. I divided each sentence into like different phenome wise parts. If I'm saying hello, I'm Nandita, I would divide that hello into like H, and then how H will be spoken, how E will be spoken, how LL will be spoken, and then how O will be spoken. And then I created my data set like that for like every phenome that has closed lip will be saved here. Every phenome with teeth touching kind of lip shape will be stored here. So if I open this will have 4 frames, like depends on the frame. All of the images in this are touching the teeth. So this is how I prepared my data set. I cropped it because again the dataset was being really heavy, so I cropped only the lip. I detected the lips and I cropped it by padding it by 10, so that I can have more images and do the training a little bit faster. And then after training, this is where I stored all my models. Because my runtime was getting disconnected, I have stored every like 10 epochs, generator and discriminator right here. And these are like while training, I could also see how much it is improving. So if this is like 70th epoch, this is like as it's improving. This is how it is. Yeah. Also each epoch has like 3 frames, 2 frames, because it was supposed to be a video, so we need like chained frames. So yes, that is how I have saved my model, and then I'm using that model to generate like in the front end here to generate these images. I'm sorry for the quality. And this is how many words we made. Like to try it out. Let's go for sorry. Let's see how sorry looks. So sorry. It's only a little accurate. Like I think the accuracy is not the problem, the quality is the problem. The dataset, the classes in which the dataset was less has a little lower quality than the others. I think the closed lip one had a lot of like it was rich in quality, so all those teeth touching closed lip, the first few I had a lot of images, so they are much better than these where nothing, it's neither closed, it's just rounded lip. That's it. That's all about my project. Thank you so much.